This is the third video from a series of videos covering linear relationships from the NSW Stage 5.2 mathematics syllabus. In this video, I'm going to look more closely at connecting graphs to their equations. So starting with an equation, quickly drawing the graph, relevant graph, and then if you're given a graph, a straight line, how do you derive its equation? So let's look at an example. Let's say we have a really common example, y equals 2x plus 1. We know the y-intercept is 1 and we know the gradient is 2. Now I'm going to label my axes, and I know my y-intercept is 1, so let's just put some markings on my axes. So it's going to cut the axis at 1, and we know that to sketch a straight line we either need 1 point and gradient, or we need 2 points. They're the two options, minimum amount of information to be able to sketch a straight line. In this case I have a point and a gradient. The gradient, remembering, is rise over run, so I'm rising 2 units for every 1 unit across. So if I go 1 unit across, I need to go 2 units up. So my line must pass through those 2 points. So then I can go ahead and draw a straight line, remembering to put arrows at both ends of the line. It's always good to label your line, especially if you're drawing more than one line on a graph, then you can identify the lines. And it's also good, well, you should label your markings, and it's good to label at least one of the points you're working with. What happens if the equation is just y equals 3x? We looked at this in the previous video. In this case, the y-intercept is 0, so that would be here, and for every 1 unit across I am moving 3 units up, so it would pass through this point as well, and then I can draw a line through those 2 points. So these 2 lines intersect at point 1, 2, and I'm going to label my line as y equals 3x. Let's look at another equation. What if I had y equals 5? The x is missing here. The coefficient of x here must be 0, because we know 0 times anything results in 0, which makes that x term disappear. So the gradient here is 0 and the y-intercept is 5. So for this function I am cutting through 5. 1, 2, 3, 4, 5. That's my y-intercept, and my gradient is 0, so I am going to have a straight line passing through 5. There is another one that's very similar to this. X equals, say, -2. Now in this case I don't have a y, I don't have a coefficient of x. Well, I do really. The coefficient of x is 1, but it's not what we're used to. It's not y equals mx plus b. So what happens here? Well, that -2 or 2 is not a y-intercept. In this case, just like before, in where we had y equals 5, which really meant, irrelevant of what the x value is, the y value is always 5. So we ignored the x's and we're just focusing on y. For this equation, the x values are always -2 irrelevant of what y values we're working with. So if I go to -2, that means any point, as long as its x value is -2, is acceptable. So I end up with a vertical line. Now, we know that the gradient of this line is 0. No line could be any steeper than this line. This is maximum steepness. So you could think of this gradient as infinity, but infinity is really a concept, so sometimes we'll talk about the gradient being undefined. Another way, a more mathematical reasoning for this is gradient is rise over run. So whatever the rise is per 1 unit of run, except this line has no run. It doesn't move left or right at all. It goes straight up. So you end up with run being 0, and we know in mathematics we can't divide something by 0. Therefore it's undefined. Okay, so that's a really quick explanation of using a gradient and a point to sketch the graph. Let's now look at the other way around. Let's draw a line and see if we can figure out its equation. So in this case, I have my y-intercept. I can read that straight away. My y-intercept is 2, so the y-intercept occurs at 0, 2. All I need is the gradient, and the gradient is rise over run. So I just need to create a triangle, a right angle triangle, from which I can work out my rise over run. In this case, right angle triangle, straight forward, I can use the origin as my vertex. And you can see that as we move from left to right, we don't actually have rise, we have a drop. That's our negative gradient. So the rise is 2, or the drop in this case, and the run is 2 for the triangle. That gives me -1. So the equation of this line is y equals my m x plus my y-intercept. A simpler way of writing that is -x plus 2. Let's look at another example. So for this example, again, the first thing I do is look for my y-intercept. We can see that the y-intercept happens at 3. So my y-intercept occurs at 0, 3. And I need the gradient. Again, I look for a right angle triangle. You could make any right angle triangle you like. You could use this here. I could make a right angle triangle here. But there is an obvious one, again with the origin forming my 90-degree vertex. And I can see really quickly that my run is 6 and my rise is 3. So let's write gradient rise over run, and that would be rise of 3, run of 6, which is the same as a half. So my equation, remembering it's mx plus b, my gradient is a half x plus 3.